This video is on the value of conversion factors, and we're going to try to address three main questions in this short video. The first question is, why do you even use conversion factors? The second question is, how do you create them, and then how do you use them? And then thirdly, what are conversion factors worth? So why are conversion factors even used? So often there are different units that make the same measurements. So for example, let's say you run cross country and you know that you run the 3.1 mile cross country race in 17 minutes. And then you meet a student, a foreign exchange student, who is more familiar with the metric system, and they say that they can run a 5K race in about 18 minutes. You can decide if you are faster than this foreign exchange student or not. Secondly, and this is going to be the most important for you in class as a physics student, lots of times when we make measurements and then have to use them in a calculation, the value that's included in the formula has to be a certain unit. So for example, if you measure the mass of an object and you measure it in grams, but the formula calls for the units to be in kilograms, you'll have to be able to convert from grams into kilograms. The second question that's useful to consider is, like, how do you create them and how do you use them? So lots of times people they might know that there is 1,000 meters in 1 kilometer, but when it actually comes to converting, some students get confused about, wait, am I supposed to multiply by 1,000 or am I supposed to divide by 1,000? So I'll give you a strategy to help with that. Thirdly, what are conversion factors actually worth? Well, the beautiful thing about them is that they don't change the worth of any quantity. Rather, they just change the appearance of the value. So they just put it in the correct sort of unit or scale. In order to consider what conversion factors are used for, you're going to need to know some of the prefixes from the SI system. So there's really only three that we care about. There are lots of them, but the three that we're going to care about are kilo, centi, and milli. So the word kilo means 1,000. So if you have 1 kilometer, your conversion factor is you have 1,000 meters. So we're going to write conversion factors as equalities because 1 kilometer equals 1,000 meters. The word centi means 1/100th. So if you're looking at it, the conversion factor for this 1 centimeter is 1/100th of a meter. And lastly, the millimeter is 1/1000th. So if you have 1 millimeter, that really means you have 1/1000th of a meter. Now, sometimes it's easier for students to consider these conversion factors as whole numbers. And I mean, that makes sense to me as well. So 1 meter is really 100 centimeters, or 1 meter for the millimeter is 1,000 millimeters. Let's consider a problem that asks you to convert 35.8 centimeters into meters. So here are the steps that are necessary. So I only ask students to do 3 things. The first thing is to identify your pathway. So we're going to look and try to identify where are we starting and where do we need to go. So in this case, it's asking us to go from centimeters into meters. So centimeters to meters. So if you know the conversion factor for that pathway, for us, for example, we know that, and there's 2 ways to write it. You can either write it as 1 centimeter is equal to 1/100th of a meter, or just like in the previous slide, we said that 1 meter is 100 centimeters. So both of those are true and the same relationship. So our second step is to identify the conversion factor. Okay, and then the third step is to set up to cancel units. So in this case, we have a starting value of 35.8 centimeters, and it asks us to convert it into meters. So using these conversion factors right here, centimeters are going to go on the bottom, and meters are going to go on the top. So for example, 100 centimeters and 1 meter. So in this case, centimeters cancel. And so the only units left are left in meters. So if you follow this multiplication of this fraction, you should get the right answer. In the second practice problem, it asks us to convert 9,000 seconds into hours. And some people do know a conversion factor for these two, but if you don't know it off of the top of your head, there is a middle step you could go to instead. So we're going to demonstrate how you can go from seconds into minutes and then minutes into hours. So we're going to use this step instead. So we know that in 1 minute, there are 60 seconds. And then secondly, we know that in 1 hour, there are 60 minutes. So to take your 9,000 seconds and convert them into hours, we'll set it up so that you can divide by 60 seconds and multiply by 1 minute. And then to get rid of the minutes, we will set the minutes up in the bottom, 60 minutes, and 1 hour in the numerator. So if you take your number 9,000, multiply it by 1, multiply it by 1 again, and then you take that quantity and you divide it by 60 times 60, that would get you the right answer. This third practice problem is to demonstrate that you can convert units in both numerators and denominators. So the problem asks you to convert kilometers per hour into meters per second. So both of these values will need to be changed. So the numerator starts in kilometers and is being changed into meters. And the denominator starts as hours, as in kilometers per hour. So we will go from hours to minutes and then minutes to seconds. So from here, we'll identify the conversion factors for these. So if you remember, there are in 1 kilometer, there are 1,000 meters. And then in 1 hour, we have 60 minutes. And in 1 minute, we have 60 seconds. So our first step was to identify the pathway. That's done here in blue. The second step is to identify the conversion factors. So those are done in green. So our third step is just to set up our system so that we can cancel out the units. So if we start with 35 kilometers per hour, this is 1 hour, we should set up to cancel kilometers. So kilometers will go down here and meters will go up here. To continue canceling units, we're going to want to get rid of hours from the denominator. So this time hours needs to go in the numerator. And our only conversion is from hours to minutes. And then we have minutes to seconds. So minutes will go here and seconds will go here. So from here, we take our values and put them in the places where they need to go. So 1 kilometer goes here, and we have 1,000 meters going there. Secondly, we have to convert the denominator, so hour and minutes. So these values, you have 1 hour is in 60 minutes. And then the third one is 1 minute has 60 seconds. So if you set your multiplication problem up like this, you understand that 35 kilometers per hour converts to meters per second by taking the 35 kilometers multiplied by 1,000 meters and then multiply by 1 and by 1. So the numerator is 35 times 1,000. And then the new denominator is the 1 times 60 times 60. So if you set the math problem up in this way, you'll be able to get your final answer. The last question I'd like to leave you with is what you call a fish without an eye. So that's it for the value of conversion factors. See me if you have any questions.